Hello everyone. So in this particular video, we will see what is the concept of orthonormality or what the orthonormal word means when it comes to calling the vectors being orthonormal. So in the earlier video, we have seen that two vectors are orthogonals when they are perpendicular to each other. So if I have two vectors v1 and v2, if both the vectors form 90-degree with each other, then we call these vectors orthogonal to each other. Okay. Now the orthonormality has one additional term, that is the normality, or the vector being normal, and it is related to the length of the vector. So if the vectors that are orthogonal have a length or a magnitude of 1, then we say that the vectors are orthonormal. So orthonormal has two components. First is the vector should need, that is, the vector should be orthogonal, and the second part is that the vectors should have unit length or the magnitude should be 1. We can see and look into this example where we have taken vectors in the same coordinate frame system. Let us call it x and y, and call this also x and y. And in this particular coordinate frame, we have taken two vectors. So again, the orthonormal vectors should be in the same frame of reference. It is not like that one vector is in one coordinate frame and the other is in the different coordinate frame. Then we cannot talk about the vectors being orthonormal. They should be represented in the same frame of reference or the same coordinate frame. So as in this particular case, we have two vectors v1 and v2. One is along the x-axis and other is along the y-axis. And these are the vectors v1 and v2. As we have seen in the orthogonal video, and as we can see pictorially here, that both the vectors are forming 90-degree with each other. So with this, we can say the vector v1 and v2 both are orthogonal, and they are orthogonal to each other. The second component that we have to check is whether their magnitude or the length of the vector is 1 or not. So this can be done by finding the magnitude of the vectors v1 and v2, and both of them is have a magnitude of 1. So we see that vector v1 and v2 are orthogonal and their length or their magnitude is 1. If both the conditions are satisfied, then we say that the vector are orthonormal. So orthogonal plus the vectors are normal. In a similar situation, if we look into two vectors where vector v3 is 1 1 and vector v4 is 1 -1, we see that the angle between the vectors is 90-degree. So if that is true, then the vector v3 and v4 are orthogonal to each other. Both the vectors are orthogonal to each other. Now we have to check the second condition, what? The length or the magnitude. We again find the magnitude of the vectors v3 and v4, and it is square root of 2. Both the vectors are of equal length and the length of the vectors is square root 2. So this is not a unit length vector. It is not a unit length vector. So if the vectors are not of unit length or the magnitude is not 1, then these vectors are not normalized vectors. Okay. And if the vectors are not normalized but they are orthogonal, then they are simply orthogonal vectors and not orthonormal. Not. Okay. So we see a set of vectors v1 and v2. This set is a orthonormal set. If we consider a set of vector v considering two vectors v1 and v2, then this is an orthonormal set and both the vectors are orthonormal to each other. If we have another set of vector where vector are v3 and v4, then this is a orthogonal set, not orthonormal, as the vectors are not having unit length. Now, what is the application of this particular orthonormality principle? It will be used in finding the basis for a particular vector space. So we will see how finding a set of orthonormal vectors eases the task of finding the basis of a vector space. So for example, we can see that in case of 2D vector space, we have two vectors and both are orthonormal and they form the basis. And in case of 3D vector space, we have three vectors each towards the x-axis, y-axis, and z-axis, and they form the basis for the 3D space. So we will look into the application of finding the set of orthonormal vectors, and it helps in finding the basis of a vector space. So that's it. This is what orthonormality means. The vector should be orthogonal, plus the vectors should be orthogonal to each other and of unit length. So that's it for today. Thank you.